Hello and welcome to this video about writing half equations. We're going to be looking at half equations for both bonding and electrolysis. This is a subject that a lot of students struggle to wrap their head around, but I find the best way to think about it is to consider bonding and electrolysis as opposites. A lot of students can grasp the concept of atoms losing or gaining electrons to form ions in bonding, so losing electrons gives a positive ion and gaining electrons gives a negative ion. The oppositely charged ions are then attracted to each other in ionic bonding, forming the compound. So we've gone from individual elements to forming a compound made of multiple elements. The problem seems to come when you need to talk about what's going on during electrolysis, but it's just the exact opposite. So you're starting with the compound and splitting it apart to form the individual elements again. So to do this, you have to turn the ions back into the neutral atoms again. So you do the opposite of what happened to turn them into ions in the first place. So the positive ion was originally formed from an atom by losing electrons, so to become the neutral atom again, it must gain electrons. On the other hand, the negative ion originally gained electrons when it formed the ion, so to become neutral again, it must lose those electrons. Let's take a look at an example to explain this a little bit more. This diagram shows the process of bonding and then subsequent electrolysis of sodium chloride. You can see in bonding that the sodium loses its outer electron, which gives you this positive sodium ion. This lost electron is then transferred to chlorine, so that shows that it has gained the electron and becomes negatively charged. You then have the two oppositely charged ions that are bonded together by the electrostatic attraction between them. Now, if you look at the electrolysis process, you are starting with the two ions that are attracted to each other. Now, to be discharged from the electrolysis cell as neutral atoms, so as the elements we started with, the opposite process has to happen. The negative chloride ion has to lose the electron it originally gained to become the ion. The chlorine is now a neutral atom again. There's a little bit more to discharging chlorine as it exists as a diatomic molecule, so that's two atoms joined together, but we'll come back to this. The electron that the chloride ion lost transfers back to the sodium ion, so it gains this electron and becomes a neutral atom again. So we can start to turn this information into our half equations now. So half equations for chemistry are a little bit different than the half equations you may be used to in physics that are linked to radioactivity. So they show what's going on with the electrons during electrolysis or just during reduction and oxidation in general, in chemical reactions, in bonding, that sort of thing. Do you remember what is oxidation reduction? We have the saying oil rig. What this means is oxidation is loss of electrons and reduction is gain of electrons. So anytime you are talking about losing electrons, you are talking about the process of oxidation. And if you're talking about gaining electrons, you are talking about the process of reduction. So let's make the information from the previous slide look a little bit more like a chemical equation. So we showed each sodium atom losing one electron to become the Na plus ion or the sodium ion, and each chlorine atom gained one electron to become the chloride ion or the Cl minus ion. For electrolysis, we saw the opposite happen. So each sodium ion gained one electron to become the neutral sodium atom, and each chloride ion lost one electron to become the neutral chlorine atom again. So we're getting close to these actually being half equations where we need to add in the electrons. We're going to come on to that in a second. In the meantime, let's work out whether these show reduction or oxidation. So in bonding, sodium loses an electron, so that is oxidation, or it is oxidized, and the chlorine gains one electron, so that is reduction, or we'd say that it has been reduced. So it works that electrolysis has to be the opposite. The sodium ions have to be reduced to form the atoms again, and the chloride ions must be oxidized to form the atoms again. So again, going back to that opposite process. So let's start adding in electrons and turn these properly into our half equations. So in simple equations, you use the formula for the elements, ions, and compounds that you need to be able to describe the reaction. So, things like if you're talking about water, you'd be using the formula H2O. Half equations also need a symbol to represent electrons, as we'll need to show where they are lost and gained from, and it's a very simple symbol. We use E minus, so that's a little superscript minus up at the top. So you use it in your equations just like you would use formulae in a normal simple equation. You can have multiples of the electrons, and you can put a coefficient, so that's the big number that you use in balancing. You can put that in front of this symbol if you need. So for example, if you're gaining 3 electrons, you would need to have 3e minus, just like this. So let's have a look at putting these into the equations we had sort of started to write. So there they are. I've just put some spaces in them for where we are going to put our electrons. So we know that sodium is going to lose 1 electron during bonding to get its full outer shell, which is one of those E minus symbols. But how do we show this? Well, it's just like in maths. If we're losing or taking away that electron, we use a subtract symbol. So we'd get Na minus 1E minus, which gives us this Na plus. So it's just like it is in maths. You can think of it like you're doing a little sum. So that's one way of showing the oxidation reaction, and that's acceptable for GCSE using this subtract symbol, which we don't normally see in these kinds of equations, in chemical equations, but we can use it for our half equations at GCSE. However, for A level, you would be penalised for writing it this way, and the way that it must be shown at A level is this way around. So you're sort of showing the electrons as a product instead. It's technically the more correct way of doing it, but when you're first starting out with showing your half equations, it can be a little bit more confusing. So for GCSE, feel free to say that when oxidation is happening, you are minusing electrons. That's absolutely fine to show. So let's take a look at chlorine again during bonding. So you'll notice something different from earlier. Previously, we had just been writing Cl as the elemental form for chlorine, but that's not quite right. It exists in nature as Cl2, which would be the same for any of the halogens, as well as oxygen, nitrogen, and hydrogen. So you must always make sure for these elements that you're starting and ending with this diatomic molecule. Diatomic just means 2 atoms joined together. So all this means is that we have to make sure we are balancing our half equation just like we would need to for any other chemical equation. So if we start looking at chlorine, each chlorine atom must gain 1 electron to get a full outer shell. So we show that as plus 1e minus. However, we have to remember that there are 2 chlorine atoms here in our molecule. So we need to show that in total, 2 electrons must be gained by the chlorine molecule. So we need to make the coefficient in front of the symbol a 2. So that shows in total we have gained 2 electrons because we have gained 1 for each of the chlorines that are here in this molecule. It's still not quite balanced yet because we need to also make sure that we are showing 2 chloride ions are formed. So again, we have to have a coefficient here in front of the Cl- to show that we are making 2 of those Cl- ions. So overall, it still needs to be balanced. You still need to have the same number of atoms of each element on each side. So now we're going to have a look at electrolysis, which means our half equations are going to be the opposite of what they were for bonding. So this time we're showing our sodium ion returning to a neutral atom. So this time the ion is going to be gaining 1 electron. So it's nice and simple, it's just plus E minus. So that looks, a lot more similar to a normal chemical equation, apart from we've got electrons in there. So on the other side, we have our negative ion that is going back to being a neutral atom. So again, each chloride ion is going to be losing 1 electron to be neutral again. So we can show that as minus E minus. Now, as before, we're going to have to think about balancing this half equation. So to start with, we have 2 chloride ions. So we've got to remember that there's going to be 2 because at the end, we're going to end up with the diatomic molecule again. So we have to make sure that we're coming in with 2 chloride ions, otherwise it's not going to balance overall. And again, if there are 2 chloride ions, that also means that there have to be 2 electrons lost, as there is 1 lost from each ion. So we also have to put a 2 in front of the electrons to balance it up. Again, with the as with the symbol for sodium, there are two ways this could be written. So using the subtract symbol, which I've already done, is fine for GCSE, but this would be the way that you would write it for A level. So again, kind of showing those electrons as a product rather than as one of the reactants or something being subtracted. But again, you only really need to worry about writing it that way for A level. If you want to stick with using the subtract symbol for GCSE, then you absolutely can. It's also quite common after these sorts of half equations to be asked to decide whether they show oxidation or reduction. We did talk about this on the previous slide, but there they are again as a bit of a recap, and you can kind of see a little bit more clearly what is going on in these reactions now that we have shown the electrons being transferred. So a few final things to bear in mind when we are writing half equations. So you need to know whether you're dealing with a diatomic molecule for the negative ion. This will usually be the case, and for electrolysis it will often be a halogen or oxygen. Make sure you are balancing the number of electrons and ions, and you need to be especially careful with oxygen, as each oxygen atom gains 2 electrons to form the ion in bonding, and then the oxygen ions will each lose 2 electrons during electrolysis. So you've got to make sure that you're balancing that carefully. You also need to know what the charges are for the groups and to be able to work out how many electrons are gained or lost during bonding and electrolysis. Remember that this is all about getting full outer shells for bonding, so you can work out the number gained or lost from that. If it's a transition metal that you are asked about, the charge may be given to you in the question as Roman numerals in brackets, and they will always be positive, so whatever that number is and a plus is going to give you your charge, or they may just give it more explicitly in the question, for example saying that you've got lead as Pb2+. So I hope this explanation makes half equations a little bit clearer. They're challenging at first, but you can just keep practicing these. And thank you for watching today.